What's good, Logan? So this is a quick video, at least I hope it's going to be quick, to explain logarithms and logarithmic functions. So my goal really today is that you're going to be able to evaluate logarithms. That's really what I'd like to see. So how to evaluate logarithms. Now, the question that we want to ask at the beginning is, what is a logarithm? And to do that, we need to start off with a basic premise. So my premise is that we all know that 5 to the power of 1 is 5. And I think we can all start with that. So everyone would say 5 to the power of 1 is 5. We can also go with the understanding that 5 to the power of 2 is equal to 25. Now, if 5 to the power of 2 is equal to 25 and 5 to the power of 1 is equal to 5, my question then is what is there a way to get a number that's between 5 and 25, right? So what would the x be if x was the exponent, right? So what would you have to have? How many 5s would you need to get something like 19, right? Something not completely simple. And at this point, this is the inception of logarithms. It happens at this point in time. We can assume, right, and if it's a continuous function, we can assume that it's going to be some value between 1 and 2. So maybe the x is equal to like 1.8 or 1.7 or 1.1 for that matter. It's going to be something between 1 and 2 based upon how the function works, especially if you looked at the graph. But what we want to do here is it's not an actual number like a whole number. So what we're going to do then is we're going to define it as a logarithm. And this is where it gets really confusing. So suppose we have some exponential, right? So we have something, some base written to the power of x, and that equals some answer, some value. Given that, what we're going to say is that the logarithm is this guy right here. So if we go back to this, 5 to the power of 1 and 5 to the power of 2, I would say that 1 is the logarithm and 2 is the logarithm. In this case, x is the logarithm because that's what we want. We want to figure out what that x value is, so we're going to define it as this thing called the logarithm. Then we have to go a little bit further. The logarithm of what? So x, right, x, the exponent right there, that's the logarithm, right? It's the logarithm of the a value, of this thing. So if I was looking at this problem right here, then I would say that 2 is the logarithm of 25. Now, that really doesn't make sense because you're missing something. And the thing you're missing is, what is it the logarithm of, right? So 2 is the logarithm of 25 given we're talking about base 5. One more time. 2 is the logarithm, that guy right there, the exponent is the logarithm of the 25 given the base value is 5. So if I was looking at this problem, I would say that x is the logarithm of a. So x is the logarithm of a given base b. And that's where our definition of logarithm is going to come into play. So the x value, the exponent, is our logarithm. Now, there are two ways to write logarithms. You can write them in exponential form, like right there, and you can also write them in logarithmic form. So given that b to the power of x is equal to y, we can now say that the x, the exponent, now that's the one thing I want you to remember, is that the exponent's the logarithm, which sounds kind of weird because you're like, wow, how can this thing that we've been calling the exponent forever be the logarithm? Well, if my daughter walks into class and says, Daddy, I'm pretty sure every single person in class isn't thinking to themselves, oh my God, we need to call Rocco Daddy now. No, you guys all understand that I have a different name for other people. I'm recognized differently. So this, excuse me, this exponent right here can also be viewed as the logarithm. So the exponent can also be viewed as the logarithm. So if I have a logarithmic or an exponential function and I want to rewrite it into logarithmic function, then what I want to do is write the exponent first. So I just write the exponent first and I say that is equal to the logarithm of the y. And that's often referred to as the argument. So in the logarithm, that is. So x, the exponent, right? The exponent is equal to the logarithm of y, given that we're using base b. And the way I would say it is that x is equal to the log of y base b. That's how I would say that. So x is equal to the log of y base b. Now, that gives us a basic understanding, but it doesn't help us understand like how the logarithm works. So I want to start with this really, I don't want to say simple, but it's a problem that we could probably figure out why. So the question is, why is the log of 81 base 3, right? One more time. Notice I said log of 81 base 3. So why is the log of 81 base 3 equal to 4? Okay. Now remember, the logarithm, that guy right there, is always equal to our exponent. So then our question is well, what exponent should we use? And to answer this question, we need to understand, well, what are we going to repeatedly multiply by itself? And that's where the base comes into play. So we're going to multiply the base by itself as many times as we need to get the 81. Now, in this case, to get the 81, we would need to go 3 times 3, and that's not enough. So we're going to need 3 times 3 times 3. That's not enough. That's 27. We need a fourth 3. So what we're going to say is that the exponent on this number, on that base, must be 4 to get the 81 value. And that's how logarithms work. So this tells us that the log of 81 using base 3 is equal to 4, because 4 is the exponent that you would put on 3 that provides us a result of 81. Now, let's simplify. So let's take a look at a simplifying type of question. Question number 1, the log of 25 base 5. So then we need to think about, well, what is the exponent we would need that goes on that 5 to get this 25? And that would be 5 to the power of 2. So this would tell us that the logarithm, also known as the exponent, is equal to 2. The logarithm is 2 on the 5 that gives us the 25. Question number 2. We have log of 1/7 using a base of 7. Now for this one, we need to be able to take the base, which happens to be 7, and to flip it, to take the reciprocal of it. And negative exponents do that. So we're going to say that it's negative. But then we have to figure out, well, how many 7s do we need? Well, if we flip it upside down, all we need is 1/7. So we're going to go -1. Let's try this again, but this time let's take a look at a number where we're going to need repetitive multiplication. So now we have a base of 2, and the argument is 1/8. Well, that means we would need to flip the base upside down, which indicates we're going to have a negative logarithm. So we're going to say the logarithm is a negative value, and then we just have to figure out, well, how many 1/2 do we need to multiply together to get 1/8? And that is 3. The first 1/2 will give us 1/2, the second 1/2 will give us 1/4, and the third 1/2 will give us a total of 1/8. So our answer for number 3 is going to be -3. Yes. Moving on to question number 4. This is one of the special types of logarithms, the logarithm of 1 given base 8. So now we're like, well, man, that's not an 8, that's a 1. But if we think about how exponents work, there's a very specific exponent that always gives us an answer of 1. Kinda, right? Most of the times it gives us 1. And that exponent is 0. The only time this doesn't work is when the base is not 0. So we're going to say that the log of 1 base 8 is equal to 0. So remember, if this base is anything pretty much other than negative numbers or 1 or 0, the answer is always going to come out to 0 when you're taking the logarithm of 1. All right. Now that we've taken care of what a logarithm is, now what we want to do is make sure we can understand how to transfer between logarithmic form and exponential form. And that's what we're going to look at right here. So you can ignore over here. We don't need to look at that just yet. We're going to look at these two formats. So we have our exponential form in our first problem. And what we want to do is we want to convert it over to logarithmic form. My suggestion to you is always use the exponent first. Now in this case, that is our exponent. So I am going to say that -3 is equal to, and if we remember, the exponent can also be called the logarithm. So we're going to say the -3 is equal to the logarithm, right? The logarithm of, and then I always like to do the base, even though normally we would say the base after we say what we're taking the logarithm of. I like the base because the base and the exponent kind of go hand in hand with each other. In this problem, the the base ends up being 6. So we're going to say -3, the exponent, is equal to the logarithm using a base of 6 of the argument 1 over 216. All right, let's try this again. So in the second problem, what we have is our exponent is equal to x. So we're going to say that the exponent, which is x in this case, is equal to the logarithm. The exponent is always equal to the logarithm. So the exponent is equal to the logarithm given that the base is 2. My mistake. The base is 5. So we're going to say we're going to take the logarithm of something using a base of 5, and the argument for the logarithm is going to be the 20. So we're going to say that the exponent, is equal to the logarithm of 20 using base 5. The exponent, also known as the logarithm, the base of is 5, is always going to equal 20 in this case. All right, now let's convert it over in the other direction. So when I take a look at a logarithm, I always want to look at what the logarithm equals, because that is always going to be our exponent. So in this case, since the logarithm is equal to 2, I know that 2 will be our exponent. I also can see that we're using a base of 7. So that's what I'm going to start with. I'm going to start with our exponent and our base. So since our exponent is 2 and our base is 7, we're going to say 7 to the power of our exponent, or to the power of our logarithm, is equal to the argument. Now, when you look at that kind of makes sense. 7 to the power of 2 is equal to 49. Let's try it again. Let's speed it up just a bit. So we're looking at this, and I see that we're in logarithmic form, and we have our base. Our base is 3. We also know that the logarithm is always equal to the exponent. So we're going to say 3 to the negative 5 is equal to, and this is always going to equal to the argument of the logarithm, is equal to x. All right, let's speed it up again. On this problem over here, the exponent is y, and the exponent, is always equal to the logarithm. Now the base of this logarithm is the x, so we're going to say base of x, and the argument is what it equals when you take the exponential, so w. So we're going to say that x to the power of y is equal to w, that guy right there, is the same as y is equal to the logarithm of w using a base of x. Finally, our last question. So we have a base of a, we have a logarithm that equals c, so we're going to say that the logarithm is going to have a base of a given an exponent, or a logarithm of c, equaling our argument of b. All right, hopefully this helps. If it doesn't, please ask me questions, and I'll see you guys in class.